Good morning again, and for this recording I will go mainly over how to draw free body diagrams and how to solve Newton's first law. Okay, then this is the first thing that I will do. Okay, then I will say here what are really free body diagrams. It is a diagram or free body diagram, only one. Okay, then it is a diagram that illustrates all the forces acting on an object. Now, I will say also, I'd like to see the acceleration vector shown, okay, beside the free body diagram. Okay, now what are really the steps? Okay, first I will say a diagram first for all, like the problem itself, because usually I will have more than one object in my system. Now, second, I will isolate my object Number 3, I will draw my axes, the x and the y. 4, I will show all the forces. I should label all the forces and angles as well, because they are going to be very important in the solution. Now, let me do the following for maybe, I will not do this for all of these. I will do for some of them. Okay, then I will choose, and then the rest you can ask me about. Then this is the first one. I'm going to take a screenshot. I'm going to copy. I'm going to add another page here, and then I'm going to put it here. Usually the problem, of course, is going to have more words like this, but like what I understood is that this object is at rest and I don't have any other objects here other than the table. Then I will say I will isolate my object and I will draw my axes. This is my x, this is my y. And then I will represent the center of mass of the object by this dot. And then I will try to figure out what are the forces. There is the weight downward. You can write W or mg. You will have also here a normal because that object is sitting on the surface. Then this is going to be the normal. Now, for this one, since the object is at rest, this is in Newton's first law, A equals 0. Then I will not have any acceleration here. Alrighty, I want to maybe also talk about this object. Okay, this object is gonna be, again, let me, okay, make it like smaller so that I will have enough space. And then I will have my axes as well. Okay, usually this angle will be given to you, let's say 30, because I want to show my 30 on the diagram. Then I will say here, this is the dot that representing the center of the object. There is, because like the surface is here, then this is the normal. It's not at along the y, remember. Now sorry, I'm sorry, I was thinking of the other one. Okay, I need to have it slanted, it's easier for you. Okay, let's have it slanted. Then my axes, they should be slanted, it's easier. Some of you will do it not slanted, that is okay, but for me, like, I will say it's easier. I will be stuck if I will have it not slanted. Then here I will say I will have, this is the center of my object and this is the normal. Okay, and this is my x, this is my y. Okay, now the other force, it is the weight, and the weight is perpendicular to the ground. Then look here, this is gonna be my weight, the weight of that object. Now, which angle is gonna be 30? This one or this one? Think of this while I am changing the color. Of course, this is the one that is gonna be 30. Okay, now next, let me choose another one. I wanna do this one here. Here I have two masses, and these are maybe what I will, I need to do the two equation maybe or more depending on the situation, and therefore I should have two free body diagrams. I will draw my axes also here. And I should label mass 1 and mass 2. All right, and then here I will start thinking of what are really the forces on the object. Okay, the first, mass 1, I have, of course, its weight downward, M1G, or weight 1. It should be labeled M1. And here I have the normal 1. And I have that force here, which is force 1. Also, that mass on the right is going to exert a force, and this is from 2 on 1. Then this is the free body diagram for this mass. Now for mass 2, what I have, I will have, okay, let me have different colors. This is M2G. This is normal 2. And there is a force in that direction here, and that force, it equals to F to 1, but it is now F from 1 on 2, and I have the acceleration vector also in this direction, because they're gonna accelerate in the same direction. I will have also this one now. This video, I believe, is gonna be very short because it have so many images. Then I wanna maybe upload it by itself. Okay, then here I will have this, come on, screenshot, copy, and then okay, here I will say also I have an object that is at rest also over an inclined plane. Then what I will do is, the first thing I'm gonna draw slanted, okay, axes. Okay, I will have, okay, the normal is gonna be perpendicular on the surface, then it's gonna be normal 1, or no, normal. Let's assume again this is 30, then I will say also I'm gonna have the weight here, mg, and that is 30 degrees. Now, if we are going to have these two forces only, the object will accelerate downwards because we don't have anything that is gonna keep it from sliding, because part of the weight will be canceled by the normal, but there is another component of the weight that is gonna make it accelerate downward. And this is the reason why I should add that there should be friction in this direction to prevent it from sliding. And again, here my A equals 0. I hope that this is gonna be good for your like understanding the free body diagrams. And if you have any questions about the other cases, please contact me. Thank you.